This is exercise 6.3 permutations and combinations. We will discuss 4 questions in this video. Let's start with the first one. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? It's a pretty straightforward question. If you have 3 places, it means r equal to 3, and we have 1 to 9, that's 9 digits, n equal to 9, and no digit is repeated, so 9 distinct objects and 3 unique places we have. How many different permutations we can create? 9p3. Nine p3 is equal to 9 factorial divided by 9 minus 3 factorial, that's 6 factorial. Let's remember the equation. NPR equal to n factorial divided by n minus r factorial. This is how we solve such type of questions. 9 factorial divided by 6 factorial is equal to 9 factorial is 6 factorial multiply 7 multiply 8 multiply 9. So the up to 6 factorial will be eliminated from 9 factorial, and then the remaining 7, 8 and 9, if you multiply 7, 8 and 9, what we get? 504. So we can have 504 3-digit numbers. How many 4-digit numbers are there with no digits repeated? How many 4-digit number? This is not a part of the previous question. This is an independent question. So here the n is 0 to 9. How many distinct objects we have in 0 to 9? We have 10 distinct objects. It means n equal to 10. How many are we taking at a time? R. We are taking 4 of them at a time. So here we are forming 4-digit numbers. Although we have 10 distinct objects 0 to 9, we cannot treat all of them same. We have to give a special treatment to 0 because we cannot place a 0 here. If you place a 0 here, this is not a 4-digit number. So we need to put an object other than 0 here. So how many different options we can exercise in this position? Is it 10? No. If you put a 0 here, that's not acceptable. So this is, we cannot have 10 options here. We will have only 9 options. That's 1 to 9. Any number can go here. Then what about here? Once an object is assigned here, we have the remaining 9 objects here, because here we can have 0, so we can have 9 options to exercise here, and then here you will get 8, and here we get 7. So if you multiply 9, 8 and 7, you get 4,536. We get this number here. This is the answer. Now we will approach the same question with permutation theorem, where we have 10 objects, n equal to 10, but we need a special treatment here. So what we can have here are 9 different options here. So 9 multiply, but here we do not have any special treatment to the remaining objects. So once we have assigned an object here. We have 9 objects and 3 places, so that is 9 p 3 options here. Nine p3 is 9 factorial, so 9 in 9 multiply 9 factorial divided by n minus r, 9 minus 3, 6 factorial. 9 factorial divided by 6 factorial is 789. Then another 9, so we get the same numbers here. That's equal to 4536. Okay, let's go to the next question. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 5, 6, 7? How many numbers we have? 1, 2, 3, 4. These are 6 numbers, so n equal to 6. We are creating 3-digit even numbers, so we have 3 positions. Then we have a constraint that we are looking for even numbers. When we construct even numbers from these digits, numbers ending with 2, 4 and 6 are even numbers. So we will have 3 kind of sets here. The 3-digit numbers that ends with 2, 4 or 6. So these are all even numbers, 3-digit even numbers that we can construct from these. So if 2 is taken here, we have 2 places, and in these 2 places, how many possible objects we can exercise? Once 2 is gone, 1, 3, 4, 6, 7. We have 5 options here. 5 p 2. That means 2 positions and 5 numbers. 5 p 2. 5 p 2 is what? 5 multiply 4. That is 20. Then here again 5 p 2. That is 20. Another 5 p 2. 20. And how many total even numbers we have? 20 even numbers ending with 2, 20 even numbers ending with 4, 20 even numbers ending with 6, and we have total of 60 even numbers. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4 and 5. So we have n equal to 5. 5 distinct objects. No digit repeated. So we have n equal to 5. Then what we have to construct is 4-digit numbers. Four-digit. It means r equal to 4. Then how many different 4-digit numbers we can create? 5 p 4, because we can have 5 p 4 permutations from 5 distinct objects and 4 taking 4 at a time. 5 p 4. It means we can have 5 different options here, 4 options here, 3 options here and 2 options here. So if you multiply 5 multiply 4 is 20, 20 multiply 3 is 60 to 120. So we will get 120 different options. So 5p4 is equal to 120. So we can have 120 different numbers, 4-digit numbers. How many of these will be even numbers? The numbers ending with 2, 4. These are even numbers. So if you place 2 here, then we have 3 positions and 4 numbers. 4 numbers and 3 positions, that is 4p3. What is 4p3? 4 multiplied 3 multiplied 2 is 4p3, that is 24. So ending with 4, we will have another 24. So this is for 2, and if you place 4 here, we will have another 24. So we're gonna have 24 plus 24, 48 even numbers. The total 4-digit numbers we have calculated 120. That's one part of the answer. The second part of the answer is 48. These are 48 even numbers.